No disturbance in classes. Online digital lessons with HD quality transmissions. Subject experts and experienced faculty. Unlike other app, we have our own teachers for assuring 100% quality education. If you too want our quality teachings are at your premises and institutions. Not only SSC, but other various courses are in easy method covering state syllabus. We successfully taught at pre-examination period to government SSC students in COVID pandemic. We made grand success our online teachings at private colleges also. Why are you waiting? Just dial for online admissions. Rush and join in ABC Education Learning.
Hi everyone, welcome to mathematics class of ABC Educational Learning app. In previous session, students, what we have learned? Rational numbers and types. In rational numbers, there are two types, terminating and non-terminating. Rational numbers, terminating, one more, non-terminating. Terminating, already know students. For example, terminating 3 by 4, 8 by 5. These are terminating decimals. Means let x is a rational number. Rational is nothing but p by q number where depends on denominator, that is q. Q is in the form of 2 power n 5 power m. We can say directly without doing actual division, which is terminating, means x is terminate. Okay. Similarly, non-terminating, repeating or recurring decimal, non-terminating, repeating or recurring decimal. Then now we are discussing non-terminating repeating decimal. See students, let us consider a rational number that is non-terminating recurring number. For example, 1 by 3. 1 by 3 is a terminating or non-terminating? See, by using division, okay, 0.0, 3 3s are 9, 10 minus 9, 1, same, 0, 3 3s are 9, okay, this process goes continue. Then we get here quotient 3 3 3 so on. That means you can write 1 by 3 is equal 0.3 bar. When in any number in decimal expansions bar is there, that is non-terminating repeating. Which number repeat here? 3 is repeating. See one more example. Suppose 5 by 11 means we can write decimal expansion of 5 by. Already in previous session we have discussed terminating means how to convert p by q to decimal and decimal to p by q. Similarly here 1 by 3 is a decimal, then what is the p by decimal form? 0.3 bar. Then how to convert decimal to p by q for non-terminating repeating number? See one more example, 5 by 11, 5, 0.0, 11 4s are 44, 50 minus 44, 6, same, 0, 11 5s are 55, 60 minus 5, then 11 5 0, 11 4 44, 6. This process will goes continue. Then what is the decimal expansion of 5 by 11? 0.454545. Observe students here, we get 4545 is continue repeating number. Then observe here, 5 by 11 is a P by Q form. P by Q. What is the Q here? Q is equal 11. Then notice the student here, we cannot express in the form of Q is equal 2 power n into 5 power m. Okay, therefore 5 by 11 is a non-terminating repeating decimal. Is it clear, students? Now we see how to convert decimal to P by Q, rational. Okay, here take rational, then convert it into decimal. Here also same, we consider rational number, then convert it into decimal. Now decimal to rational, how to convert decimal to rational for non-terminating repeating decimals? Students, already you know 1 by 3 decimal expansion 0.3 bar. Okay, then first let x is equal 0.3 bar, that means 0.33, equation 1. What is periodicity here? Periodicity 1. Then equation 1 into 10, total equation 1 into 10, 10 into x, 10x is equal 0.33 into 10. Therefore 10x is equal 3.33, that is equation 2. Now subtract from equation 2 minus 1. Write equation 2, 10x is equal 3.33. Now equation 1, x is equal 0.33. 3 minus 3, 0. 3 minus 3, 0. 3 minus 0, 3. 10 minus 1, 9, x. X is equal 3 by 9. 3 1s are 3 3s are. X is equal 1 by 3. Already you know, students, 1 by 3 is P by Q form. What is the decimal expansion? 0.333. See here, x is equal 1 by. Take decimal converted into P by Q for non-terminating repeating decimal, students. Is it clear? Very simple. Now our next topic is irrational numbers. Or you can take one more example. Already you know, students, 5 by 11. Then what is the answer? 5 by 11? 0.45 bar. Okay. Then let x is equal 0.4545, that is equation 1. What is periodicity here? 2. Then total equation 1 multiplied by 100, that is equal 100 into x, 100x, 0.4545 into 100, 100x is equal to 4.45.4545, that is equation 2. Now subtract from equation 2 minus equation 1. 100x is equal 45.4545. Now write equation 1. X is equal 0.4545. 5 minus 5, 0, 0, 0. Okay, 45 is equal 100 minus 1, 99x. X is equal 45 by 99. 5 table. 9 5s are 9 11s are, means 5 by 11. Is it clear, students? Very simple. Already you know 5 by 11. What is the decimal expansion? 0.4545. Now take 0.45. Then what is the P by Q expansion? That is P by Q 5 by 11. Then when you know terminating, given number is terminating or non-terminating, then we have to convert into p by q to decimal and decimal to p by q. This is the process. Now our next topic is irrational numbers. Is it clear, students? Irrational numbers. In class 9th, you have studied about irrational numbers and their properties and how to locate irrational number on number line, and the relation between irrational and rational to get together made up of real number. That is also you know. Now in this session we will prove the given number is irrational or not. Given number is irrational. Then what is the meaning of irrational? The numbers which are in the form of p by q, where q not equal 0. Here which is not in the form of, that is not in the form is nothing but the number which are not rational, that is irrational numbers. Okay, for example, root 3, root 5, root 7, etc. These are irrational number. Then how to prove given number is irrational? Okay, before going to prove the irrational number, we have one theorem. Look at a theorem. What is the theorem? Okay, students? The theorem is, let p be a prime number or prime factor. P is a prime factor, then p divides a square, then p divide a also. This is a statement. Let p be a prime number, p divides a square, then p divide a also. See students, proof. Let p be a prime number, prime factor or prime number, then a is equal to p1, p2, so on pn. Then p divides a square, means we know a value, then what is the a square value? p1, p2, pn into p1, p2, pn. That means p1 square, p2 square, pn square. Okay, then here when p divides a square, means when p divides a square, then p also divide a. Let's see one example. First, suppose a is equal to, then what is the a square? 2 into 2, that means 4. How to prove this theorem? By using fundamental theorem. Already know students, fundamental theorem. Every composite number can be expressed in terms of prime factors. Fundamental theorem. By using this theorem, when a is equal to, then a square 4, means number 4 have prime products 2 into 2, means when any number divides square of given number, then it divides number 2. Okay, then for suppose 2 divides 4, then 2 divides 2 also. That is, when p divides a square, then also p also divides a number. This is a theorem. By using this theorem, given number irrational or rational, then let's see prove. Is it clear, students? Now, how to prove or show that given number irrational numbers? Prove that root 5 is an irrational. Prove that root 5 is irrational. See how to prove root 5 is a irrational. First, let us assume root 5 is irrational. Students, already you know what is rational? The numbers which are in the form of p by q. Then let us assume root 5 is a rational. That means root 5 is equal, you can take p by q, where p and q are common factor. P and q have common factor. Okay, that means, for example, take 9 by 12. Common factor, which is common here? 9 by 12. 3 is common. Then root 5 is equal, we get a by b. When divide with common factor, we get a by b. For suppose 9 by 12 is a p by q form. Then which is common factor here? 3 is common factor. When divides with common factor, we get a by b. Means 3 3s are 3 4s are. A 3 by 4 means a by b means 3 by 4. We get a by b. Then 3 and 4 have any common factor? No common factor. That means a and b are co-primes. Very simple. A and b are co-primes. Is it clear, students? Okay. Then let us assume root 5 is a rational. Means root 5 p by q, where p and q have common factor. For suppose 9 by 12. 3 3s are 3 4s are. 3 and 4 we get, when divide with common factor, we get a by b. When we get a by b, then okay, cross multiply. A is equal root 5 into b. Now squaring on both sides. Squaring on both sides. A square is equal, square root get cancelled, 5 only, then 5b square. That means, see here, b square is equal a square by 5 is nothing but, by using theorem, a square means 5 divides here, 5 divides a square. Then 5 also divides a. What is the theorem, students? Let p be any number, p divides a square, then p divides a also. Same as when a square by 5 is nothing but 5 divides a square here, then 5 also divides a. Okay, when here, students, just listen or remember one point. A and b are co-prime. Co-prime is nothing but there is no common factor other than 1. Then here a divides means when any number divides that have common factor. Similarly, see, students, let in place of a, you can write a is equal 5c, where c is some integer. Okay, then b square is equal, a square is nothing but 5c whole square divided by a square. 5c square is 25c square divided by a square. Sorry, 5. Okay, 5 1s are 5 5s are, means we get here 5c square. Okay, means b square is equal 5c square by A. Means here also same. When B, see here, B square by 5 means when B square divides by 5, then B also same. Means 5 divides B square, then 5 also divides B. When any number divide is nothing but there is a common factor, but here A and B are co-primes, right students? Okay, then let our assumption is wrong. Means given number or root 5 is a rational number, but these contradicts here, but contradicts. Okay, our assumption is wrong. Therefore we conclude that root 5 is irrational. Okay, hence proved. Very simple students. Is it clear? In place of root 5 you can take root 2, 1 by root 2, root 3, root 7, root 11, same process. You can take any number, same process. First step, let assume that root 5 is a rational. Already you know rational is nothing but P by Q form. When we know P by Q form, then but here common factor, then we get co-prime is nothing but there is no common factor. Now cross multiply and scoring on both sides. When 5 divides A square, 5 also divide A. When divide is nothing but there is a common factor. But these contradicts, our assumption will be false. Means, so we conclude that given number is a irrational number. This is the proof. Is it clear students? See one more example. In our public exam, different types of questions will be asked. Prove that root 2 plus root 3 is irrational. Next question. Prove that root 2 plus root 3 is irrational. Okay, students, what is our first step? Let us assume root 2 plus root 3 is rational. Okay, rational is what? P by Q. Means root 2 plus root 3 is equal to A by B. Okay, root 2 also irrational, root 3 also irrational. From these two, you can take any one. Root 3 is equal to A by B. See here, root 2 positive term. When we transpose positive to negative, we get negative terms. Minus root 2. Root 3 is equal LCM A minus root 2B by B. Now, see students here, observe carefully. Root 3 is a irrational number. Root 3 is a irrational. Observe here, A minus root 2B means it is totally we consider P. Then it is Q means P by Q. Means LHS term is a irrational number. RHS term is a rational number. Students, already you know rational means which numbers are contained numerator and denominator, that is P by Q form. Irrational means the numbers which is not perfect square under the root. Then see here, when irrational is equal to rational? No. This contradicts our assumption false, because irrational is not equal to rational. So we conclude that given number root 2 plus root 3 is irrational number. Is it clear, students? Very simple. Let us assume given number is a rational. Rational is what? P by Q number. P by Q. You can take A by B, R by S. Okay. Then root 3 is equal, we get here irrational is equal to rational. Okay. These contradicts arisen because our assumption wrong. So we conclude that given number root 2 plus root 3 is an irrational number. Is it clear, students? See one more question. Prove that root 2 plus root 7 is irrational. First step, already you know, students. Let us assume root 2 plus root 7 is rational. That means root 2 plus root 7 is equal to A by B. Now squaring on both sides. Squaring on both sides. Root 2 plus root 7 whole square is equal to A square by B square. Already you know, students, A plus B whole square. A plus B whole square. Already you know identity. A plus B whole square identity. That is A plus B whole square. A square plus 2AB plus B square. Okay. Then square root get cancel. 2 plus 2AB. Root 2 into root 7 into 2 plus 7 is equal to A square by B square. 2 plus 7, 9 plus 2 into root 2 into root 7. Already you know, students, root A into root B. You can write under root AB is equal to A square by B square. 9 plus 2 into root 14. 2 7s are 14 is equal to A square by B square. From here 2 root 14 is equal to A square by B square. Then plus 9 becomes minus 9. When we transpose LHS to RHS, sign will be changed. 9 root 14 is equal to A square minus 9B square divided by 2B square. Observe, student, here root 14 is a irrational and here it is P by Q, means rational. When irrational equal to rational number? No. Okay. Then our assumption will false. Therefore we conclude that given number root 2 plus root 7 is irrational number. Hence proved. Is it clear, students? Very simple. Any number given in show that or prove that given number is irrational. Just we do first step. Let us assume it is a rational number. Rational is what? P by Q number. Then root 2 plus root 7 is equal to A by B. Now squaring on both sides. By using A plus B whole square identity, you can expand it. Then 2 plus 2AB plus B square, A square by B square. Then 9 plus root 2 root 14 A square. Then here irrational is equal to rational. Okay. Then our assumption is false. Okay, so we conclude that given number root 2 plus root 7 is an irrational number. By using here we also prime factorization, that is fundamental theorem of arithmetic. Is it clear, students? Okay, for your SSC examination questions are like this: 2 plus root 3, 3 minus root 5, 2 plus 6 root into root 3, like this. Then show that or prove that given numbers are irrational numbers. Sure for your SSC questions. Okay, very simple. Let's one more question. Okay, prove that five minus root 3 is irrational. Let us assume 5 minus root 3 is rational. That means 5 minus root 3 is equal to a by b. Then root 3 is equal to, now squaring on both sides. Squaring on both sides. 5 minus root 3 whole square is equal to a square by b square. Then a minus b whole square identity. Already you know, students, a minus b whole square identity. That is a square minus 2ab plus b square. 5 square, 25 minus square root get cancelled, 3 minus 2 into 5 into root 3 is equal to a square by b square. 25 plus 3, 28 minus 2 5s are 10 root 3 is equal to a square by b square. Observe here, 10 root 3 is equal to a square by b square. Then plus 28 becomes minus 28. 10 root 3 is equal to a square minus 28 b square divided by b square. Root 3 is equal to a square minus 28 b square divided by minus 10 b square. Observe, student, here root 3 is a irrational. A square minus 28 b square divided by minus 10 b square is a rational. Okay, when irrational is equal to rational? No, these contradicts. Our assumption is false. So we conclude that given number 5 minus root 3 is a irrational number. Is it clear, students? Very simple. Okay. Then next, exponential. Already you know, students, in 8th and 9th standard you learned different exponential forms. First one, a power m into a power n is equal to a power m plus n. See, students, when bases are equal, then we can add powers. A power m, a power n, then a power m plus n. Second one, a power m by a power n. We get here a power m minus n where condition m greater than n, or a power n minus m where n greater than m, or 1 when m is equal to n. Okay students, a power m into a power n, a power m plus n, a power m by a power n, a power m minus n when m greater than n, a power n minus m, n greater than m, 1 when m is equal to n, means power will be equal. Next, a power minus m, that is equal to 1 by a power m. Then next, a power m into b power m is equal to ab whole power m. A power m divided by b power m, a by b whole power m. Next, a power m whole power n is equal to a power m n. These are laws of exponential. When we know these laws of exponential, then our next topic is logarithms. When we know these laws of exponential, then we get how to properties of logarithm. Okay. First one, a power m into a power n, a power m plus n, a power m by a power n, a power m minus n, a power minus m, that is 1 by a power m, a power m b power m is equal to ab whole power m, a power m divided by b power m, that is a divided by whole power m, a power m whole power n, that is equal to a power m into n. These are laws of exponential. Is it clear students? These are basic formulas of laws of exponential. Okay. Okay students, our next topic is logarithms. In daily life, you can see science and technology and engineering, they use logarithms. Where it will be used? Science and technology and engineering. So students, about the logarithm we will see in next class. Okay. In first chapter we will revise what are the topics. First, Euclid division lemma, and next rational and their exponential decimal forms. Next, prove that or show that irrational, and how to find LCM and HCF. Then last topic is logarithmics. So students, we will continue next very interesting topic, that is logarithm. Until then, bye. Keep on watching ABC Educational Learning app. Thank you.